Dynamic Stability Control, or DSC, is Mazda's electronic stability system designed to keep your vehicle under control during emergency situations and prevent dangerous skidding. The DSC system continuously monitors your vehicle through multiple sensors. These sensors track wheel speeds, steering input, and vehicle rotation to detect when the car might lose control. When DSC detects a problem, it responds by applying brakes to specific wheels and reducing engine power to help maintain vehicle stability and prevent accidents. Wheel speed sensors are the most critical components, monitoring each wheel's rotation speed. When one wheel spins faster than others, it indicates potential loss of traction. The steering angle sensor tells the system where the driver wants to go, allowing DSC to compare intended direction with actual vehicle movement. When the DSC malfunction warning appears on your dashboard, it means the system has detected a fault and may not be able to provide stability assistance when needed. This warning light indicates that your vehicle's electronic stability system has detected an internal fault and may not function properly during emergency maneuvers. Understanding the most common causes can help you identify the problem. Let's examine the failure statistics based on repair data from thousands of Mazda vehicles. Wheel speed sensors account for 35% of all DSC malfunctions. These sensors can fail due to contamination, damaged reluctor rings, or corroded electrical connections. Yaw rate and G sensors cause 25% of malfunctions. These sensors measure vehicle rotation and sideways forces and can drift over time or suffer physical damage. Steering angle sensor problems represent 20% of cases. These often occur after wheel alignments when the sensor isn't properly recalibrated to match the new steering position. Control module faults account for 15% of malfunctions, typically involving software corruption or internal hardware failure, requiring professional diagnosis and repair. Hydraulic system issues represent the remaining 5%, usually involving brake fluid problems or hydraulic control unit pump failures. Recent Mazda models from 2023 to 2025 feature enhanced diagnostic capabilities and improved integration with iActiveSense safety systems. Modern Mazda vehicles integrate DSC more closely with advanced safety features, making proper system calibration critical for overall vehicle safety and performance. Remember, a DSC malfunction warning should never be ignored. While your vehicle may drive normally, the safety systems that prevent skidding and loss of control may not function when you need them most. DSC troubleshooting begins with 3 essential basic checks that can resolve many common issues without expensive diagnostic equipment. After basic checks, professional diagnosis requires a Mazda IDS scanner or equivalent J2534 device. These tools provide access to live sensor data and can perform system calibrations. Wheel speed sensors are the most common failure point, accounting for 35% of DSC issues. Testing requires checking resistance values between 1,000 and 1,500 ohms and AC voltage output greater than 0.35 volts at 1 mile per hour wheel rotation. Yaw rate sensor calibration is critical after any battery disconnection or sensor replacement. The vehicle must be on a level surface with the engine running and wheels pointed straight ahead. Advanced repairs involving control module programming require specialized equipment and software. This process includes downloading the latest calibration files and performing complete system initialization. Understanding repair costs helps make informed decisions. Sensor replacement typically costs $200 to $500 per sensor, while control module replacement ranges from $800 to $1,500, including programming. The complete diagnostic process follows a systematic approach. Start with basic visual inspection, proceed to scanner diagnosis, then perform specific sensor tests based on the error codes found. Remember these critical points. 80% of DSC malfunctions are sensor-related. Proper diagnosis prevents unnecessary repairs, and calibration is essential after any component replacement. Following this systematic approach ensures reliable repairs and optimal vehicle safety.